Graphing Parabolas Part 2. In this video, we'll graph parabolas given in the form y equal ax squared plus bx plus c. We can do that in two ways. We can do it by completing the square to transform into the form of the equation that the constants make it clear where the vertex is. Or we can use a formula for the x-coordinate of the vertex from the equation ax squared plus bx plus c. The x-coordinate is equal to negative b over 2a. If a parabola is given in this form, where we have x plus or minus a constant that's squared and a multiplier outside, another constant outside, it's easy to find the vertex, because the x-coordinate is the opposite of the number inside the parentheses with x. So here the x-coordinate of the vertex is positive 4, since there's a negative 4 in parentheses, and the y-coordinate of the vertex is just given by the constant outside. So I have the vertex, and then I use the multiplier to find the width of the parabola and whether it faces up or down. So here is a parabola. The vertex is at 4, 2. X is 4, y is 2, and the multiplier is negative, so it's going to face down. And the 3 tells us that if I go over 1, I'm going to go down 3 to make a point. And I go over 1 the other direction. It's symmetric around the vertex, and so this parabola is narrow, facing down, and the vertex is at 4, 2. But it's much more common for an equation with x squared to be given in the form ax squared plus bx plus c, like this one, y equal x squared plus 6x minus 7. And it's not so easy to see the vertex when the equation is in this form. I could convert it to the x minus h, the quantity squared form, by doing a process called completing the square. If you've never done that before, you can look at a video about completing the square, but the process is pretty straightforward. I take x squared plus 6x, and I'm going to add something to that to make it a perfect square, so that it will come out to be x plus or minus something squared. Now the 7 is still there, and if I add something inside the parentheses, I had better subtract it outside. Now, when I add square and subtract square, it will be the same equation I started with. Well, what goes in here to make a perfect square? It's half of the middle term squared. So in this case, half of 6 squared is going to go in the box. Well, half of 6 is 3, and 3 squared is 9. So I'm adding 9 and subtracting 9. If I factor x squared plus 6x plus 9, I get x plus 3 times itself, or x plus 3 squared, and then subtract 7, subtract 9 gives me minus 16. So now my equation is in the form that I can read the vertex. The vertex is going to be the opposite of plus 3 or negative 3, and the y-coordinate will be negative 16. But if I have an equation in the form y equal ax squared plus bx plus c, there's a formula for the x-coordinate of the vertex of the parabola, and it's negative b over 2 times a. Now how do I find the y-coordinate of the vertex? Well, I just have to fill this value for x into the equation to find what y is equal to. The a in front of the x squared acts just like the capital A did in front of the other form of the equation, so a is going to tell whether it's opening up or down and how wide or narrow it is. Well, let's let's use that formula on the same equation and see what we get. B here is 6, so negative b is negative 6, 2 is a constant, and a is 1. So negative 6 over 2 is negative 3, and the x-coordinate of the vertex is negative 3. Now I just need to put negative 3 into the equation. Y equals x squared plus 6 times x minus 7, and x is negative 3. Well, negative 3 squared is 9, minus 18 minus 7 gives me a negative 16. So this is a quicker way to find the vertex than to transform the equation, and it's the way most people usually use. Well, let's find the vertex of this parabola. Y equals negative 3x squared plus 5x minus 2. The x-coordinate is going to be given by minus b over 2a. b is 5 and a is negative 3. So negative 5 over 2 times negative 3 gives me negative 5 over negative 6, or positive 5/6. If I put that 5/6 back into the equation to find the y-coordinate of the vertex, I just plop it in for x in each spot and multiply it out. Well, 5/6 squared is 25 over 36, and 3 goes into 36 and leaves 12, so I have negative 25/12 plus 25/6 minus 2, and that has a common denominator of 12, so I'll multiply 25 over 6 by 2 over 2, and I'll multiply 2 by 12 over 12, and that gives me minus 25 over 12 plus 50 over 12 minus 24 over 12. Minus 25 plus 50 gives me 25, and 25 minus 24 is 1, so 1/12. 1/12 is the y-coordinate of the vertex. Well, let's graph that. The vertex is at 5/6, 1/12. So 5/6 is almost to 1, and 1/12 is barely up above, like that. And the minus 3 means it faces down. And if I go 1 over, I'm going to be 3 down. Oops. And there we go. There's the parabola.